All right, so Unit 4, we're going to continue with Unit 4 now. We're going to go into Section 4.3. And so in Section 4.3, we're going to start talking about parallel and perpendicular lines. And we're going to also start focusing in on the slopes of these lines. Okay, so let's get started. Okay, so first off, we're talking about slopes. We can classify slopes in 4 different categories. Okay, so a positive slope, which is going to go up from left to right. Okay, it's like we're going uphill. A negative slope, which will go down from left to right. Okay, and it's important to note that the positive and negative slopes don't always necessarily have to be this drastic. Okay, they can be more of a gradual incline, or they can also be even more drastic than shown so far. Same for the negative. Negative can be more of a gradual decline or more drastic. Just any line that is going uphill will have a positive slope. Any line going downhill will have a negative slope. Okay, then we got two other categories. We've got a line that has a slope of 0. So this line is just going to look like a horizontal line. It's going to look like a flat horizontal line that will be parallel with my x-axis. And so the actual slope of this line is going to be 0 over some number. Okay, so it can be any number. 0 divided by any number will just be 0. And then the last way we can define slopes will be undefined. Okay, so an undefined slope will be a vertical line, will be an up and down line that will be parallel to the y-axis. Okay, and the slope of this will be some number over 0. Okay, so anytime we have any kind of number divided by 0, it's going to be an undefined. It's going to be an undefined number. So if we have a slope that's written as number over 0, then it's going to be an undefined slope. Okay, so now let's talk about how to actually determine the slope of a line. Okay, so if you've got any 2 points, we already learned back in Unit 1 that through any 2 points there exists exactly one line. Okay, so if we take those 2 points that are on that one line, we can determine what the slope of that line is by using this slope formula right here. Okay, so the slope formula reads as m, and m is going to represent our slope. So m is equal to y2 minus y1 over x2 minus x1. Okay, and we can use this formula so long as we have 2 points, and my 2 points being x1, y1, and x2, y2. So as long as we have the 2 points that are on that given line, we can take them and just plug them in as needed. So we can take y2, put it there, minus the y1, put it there, x2, put it there, minus the x1. So let's see an example of this. Okay, so example 1, we're given points A and B, A at 3, 1, B at negative 2, 1, and we're asked to determine how to find the slope in these two. So I'd set it up as y2 minus y1 over x2 minus x1. So 1 minus 1 would give me 0. Negative 2 minus 3 would give me negative 5. And 0 divided by any number will just be 0. So my slope of this line will have a slope of 0. So it will just be a flat horizontal line. Okay, example 2. So negative 4, 3, negative 4, 7. So we take 7 minus 3, y2 minus y1, over x2 minus x1. So we get 7 minus 3, and then down here, so we had x2, negative 4, minus x1. So since x1 was also negative 4, we had a minus negative, so we change that to a positive. So it becomes negative 4 plus 4. So that would be 0. So we have 4 over 0, which will be an undefined slope. Okay, and last up we had example 3. Okay, so this time they just gave us 2 points that were on here. Okay, and we had to determine what the slope of that line that passed through those 2 points is. So I just went ahead and named these 2 points A and B, and I determined that A was at negative 9, 3, B was at 2, 5. So I just went through and did my slope formula. y2 minus y1, so that's 5 minus negative 3, which will turn into 5 plus 3. And then 2 minus negative 9, so that'll become 2 plus 9. So my slope of this line will be 8 over 11. All right, so next up, let's talk about parallel lines, okay? So we're talking about two lines that are parallel. They are parallel because of their slope. So parallel lines are going to have the same slope, okay? And we know that parallel lines, we've already learned that two parallel lines are going to be lines that are never going to intersect. They are going in the same direction, in both directions, but they will never intersect at any point. That's what makes them parallel lines. And they are parallel lines because of their slope. Okay, so with these first two examples, we're given two sets of points, A and B, C and D. We're told that there's a line that goes through them. So there's a line AB that exists and a line CD that exists. And so we're asked to determine if these two lines, AB and CD, are parallel, perpendicular, or neither. So the way for us to determine that is we need to figure out what their slope is. So remind ourselves of what the slope formula is. It is m is equal to y2 minus y1 over x2 minus x1. So let's start with AB. So my points are negative 7, 6 and negative 6, 9. So I'll take it. Y2 minus y1, 9 minus 6, over negative 6 minus negative 7, which will become negative 6 plus 7. So my slope of AB will turn out to be 3. So now I'm going to go through the same thing with CD. So y2 minus y1 over x2 minus x1 comes out to also be 3. So since these two lines both have a slope of 3, that means that these lines are parallel. They will never intersect with one another. Okay, let's look at example 2. So given two new sets of points, again, we're asked to determine if the lines A, B, and CD are parallel, perpendicular, or neither. So we set up AB. We have 2 minus 6 over negative 9 minus 3. We wind up with 1/3. CD, we have 3 minus 4 over 2 minus 5. We again wind up with 1/3. So again, because we have the same slope for both lines, that means that these are going to be parallel. Okay, and this little symbol right here that I wrote, okay, so line AB is parallel to line CD. So the symbol for two things being parallel is this set of lines right here. Okay, so that just means parallel. Okay, let's keep looking. All right, so this time we are given again two sets of points that represent two lines, A, B, and C, D. We're asked to go through and determine if these lines are parallel, perpendicular, or neither. And then we need to graph them in order to verify our answer. So let's start with finding the slopes. So we start with AB. We have 4 minus 5, give me negative 1, over 4 minus 1, give me 3. So the first one's going to have a slope of negative 1 over 3. And this top line is going to be where I represent AB. Okay, so A was at 1, 5, B was at 4, 4. So this is my line right here with a slope of negative 1/3. You can see that it's going downhill, so we know that it is indeed a negative slope. Next, we look at CD. So negative 5 minus negative 10 becomes negative 5 plus 10 over negative 6 minus 9. So we'll wind up with 5 over negative 15. We can simplify it down to negative 1 over 3. And then once again, I just went ahead and graphed it as well. So both of them do have a slope of negative 1/3. So we know that they're parallel. And then we went ahead and graphed the two lines to verify our answer. Okay, example 4, same thing. So we'll take 7 minus 1 over negative 2 minus 8. We wind up with 6 over negative 10, which can reduce down to negative 3/5. Then we take negative 1 minus 2 over negative 1 minus negative 6, which will turn into negative 1 plus 6. And we again wind up with negative 3/5. So same slope means they must be parallel, and we just graphed it to verify that. All right, so lastly, we'll talk about perpendicular lines, okay? So perpendicular lines are two lines that intersect in such a way that they create right angles, okay? So a common example of what you might see is maybe like this, okay? So kind of like your basic coordinate grid, and at all four of these angles that are created are right angles, as shown with that little box there. Now, it doesn't necessarily always have to look exactly like a T. We could have something more like this, which again That would also be a case of perpendicular lines. So perpendicular lines are just two lines that intersect in such a way that they create 90-degree right angles. So if we're talking about the slopes of perpendicular lines, their slopes are going to be opposite reciprocals. Okay, so opposite reciprocal tells me two things. Okay, so if I'm going to talk about two numbers that are opposite reciprocals, the opposite part tells me they have different signs. So one's got to be positive, one's got to be negative. That has to happen. And the reciprocal part is that they are both the inverse of each other. What I mean when I say that is that if I was to write these two as fractions and then I just flip the fractions, they would look like the other one. Okay, so an example of two numbers that would be opposite reciprocals could be 2/3 and -3/2. Okay, so 2/3 and -3/2, one is positive, one is negative. If I flip 2/3, it's going to look like 3/2. If I flip 3/2, it's going to look like 2/3. So these numbers are opposite reciprocals. So on these first two examples, I need to determine once again if the line passing through AB and the line passing through CD, if those lines are parallel, perpendicular, or neither, and I'm going to determine that from using their slopes. So remind myself once again what the slope formula is. M is equal to y2 minus y1 over x2 minus x1. So let's figure out what the slope of AB is. So 5 minus 4 over 4 minus 2, going to wind up with 1/2. And then for CD, -7 minus 1 over 8 minus 4, going to wind up with -8 over 4, which will reduce down to -2. So if we're looking at 1/2 and -2, they're not the same number, so these lines aren't going to be parallel. So now we need to determine if these numbers can be perpendicular. Well, -2 can also be written as -2 over 1. So now if I compare 1/2 and -2, one's positive, one's negative. If I flip 1/2, it looks like 2. If I flip 2, it looks like 1/2. So these two lines are going to be perpendicular with one another. And the way I'm going to write that is line AB is perpendicular. That's the symbol for perpendicular, an upside down capital T. It's that symbol because it literally creates right angles. So line AB is perpendicular to line CD. Okay, let's go through and look at example 2 now. So example 2, we've got A and B, C and D. So let's go through and determine if they're parallel or perpendicular. 2 minus -3 becomes 2 plus 3 over 0 minus 1 becomes -1. So I've got a slope of -5 for line AB. For line CD, 2 minus 0 over 8 minus -2. I'll wind up with 2 over, excuse me. Okay, so I actually had a typo on that last one. So it said 2 minus 0 over 8 plus 10, and I got a little bit ahead of myself because it was supposed to be 8 minus -2. 8 plus 2 would give me 10. So I apologize for that. But I would get 2 over 10, which reduced down to 1/5. -5 can also be rewritten as -5 over 1. So I can tell pretty quickly that these two numbers are opposite reciprocals. So line AB will be perpendicular to line CD. Okay, so now let's look at examples 3 and 4. Okay, so again, asked to determine if these two lines are parallel, perpendicular, or neither, and then graph my lines to verify. So I'm told points A and B, so 0 minus 3 will give me -3, 8 minus 5 will give me +3, so I have -3 over 3 will give me -1. Then we look at CD, 10 minus 2 will give me 8, 1 minus -7 will give me 8, so I have 8 over 8 is 1. And so -1 and 1, that looks a little bit weird, but if I was to rewrite these, be -1 over 1 and 1 over 1, one's negative, one's positive. If I flip them, they still look like the other one. So these two are going to be perpendicular. And then the same deal for over here. Have A, B, and C, D. 3 minus 4 give me -1. 4 minus 8 will give me -4. That'll turn into 1/4. -1 minus -9 will be -1 plus 9. 2 minus 4, 8 over -2 give me -4. These two will be opposite reciprocals, and so these two lines will be perpendicular as well. And then you can graph both examples to verify.